Operators in Python. In Python, there are many different types of operators. We will go through each type with also some examples, and then we will practice each type in Visual Studio Code as well. First, we have arithmetic operators. Probably you have seen these operators before at school. You have add operator for addition, and then you have minus operator for subtraction. And here with an example, imagine that x and y are two numbers. You add these two together, you subtract one from another, and then you have a star sign for multiplication, x times y. Slash sign is used, or slash sign or slash character is used for division, x divided by y. And then you have percentage sign for modulus or the remainder of division. And then you have double stars exponentiation, which is x to the power of y. Here is a real example. 2 star star 3 is the same as 2 to the power of 3, and it is like 2 times 2 times 2, which results to 8. Then you have floor division, which is the result of division rounding to the nearest integer. It returns the result of x divided by y and rounded to the nearest integer. Today my voice is a little bit different because I am a little sick, so sorry for that. Then we have comparison operators. Comparison operators are used to check if two values are the same or not. If two values are not the same, is greater, less than or equal, and etc. As you see, this is to check the equal, double equal sign for equal. Is x equal to y, or x is the same as y? And then you have not equal. Is x not the same as y? It's not equal to that. And then greater than, angle bracket for greater than, opening angle bracket for less than. Is x less than y? And then greater than and equal to. Is x greater than or equal to y? Then less than or equal to. Is x less than or equal to y? We have logical operators. In Python, you use the English words and or not for logical operators, and returns true if both statements are true. For example, is x less than 5 and x less than 10? If this returns true and this is true, then the whole statement is true and it returns true. Or returns true if one of the statements is true. If one of these, x less than 5 or x less than 4, is true, then it returns true. Not reverses the result. So if it is false, it returns true, and if it is true, it returns false. Professional, experienced developers use not much more than junior developers, because using not is shorter and much more clear. Then we have identity operators. You have is and is not. Is x is y. It returns true if both variables are the same object. If both are the same thing with the same address in the memory, it returns true. Even if both are the same value but with different address in the memory, it returns false. Is not is the opposite of that, so returns true if both variables are not the same object. Membership operators You have in and not in. You use in and not in operators to see if an item or an object is present in another object. In returns true if a sequence with the specified value is present in the object. X and Y. You have not in returns true if a sequence with the specified value is not present in the object. X not in Y. Bitwise operators. Bitwise operators or binary operators. When you do bitwise operators on decimal number, in the background it does the operation on binary and then returns the result. If you do bitwise operators and you get a very strange number, that's okay, because that is the result of the binary operation. Here you have and operator sets each bit to 1 if both bits are 1. So if x is one number and y is another number, the compiler converts both numbers to binary and then does the operation and returns the result. Or sets each bit to 1 if one of two bits is 1. Now this is just the theory. In practice, with real examples, it will be much understandable and simple. You have XOR sets each bit to 1 if only one of two bits is 1. Not inverts all the bits. If there is 0, it inverts that to 1. If it is 1, inverts to 0. Then you have this operator. It is called zero fill left shift. Shift left by pushing zeros in from the right and let the leftmost bits fall off. And the next one is signed right shift. Shift right by pushing copies of the leftmost bit in from the left and let the rightmost bits fall off. Assignment operators. Assignment operators are used to assign value to a variable and doing some arithmetic or bitwise operations at the same time. First one is equal sign, that you assign a value to a variable. Then you have add sign and equal sign. It is same as doing x assign the original value by adding 3 on it. In this example, you can add any number you want. That's just an example. This is just shorthand. And then you have shorthand subtraction, that you subtracted a number from the original value. And then the next one is multiplication. You multiply a number with the original value. Then you have division. This is the shorthand, and this is how it is, that you divide the original number by that number. You have modulus or remainder. Then you have floor division. So what it does, it divides the original value of x by 3 and round it to the nearest integer and assign it to the x. Assignment operators except the assignment itself, except this one. The rest of them just modify the original value. Then you have exponentiation. It means the original value to the power of the specified number. And then you can do bitwise operator also with the assignment operators. If it is not clear now, don't worry. We will do a lot of examples of this, and then you will see them in action and you will understand. Operator precedence, or the order of operator. It is very important that you know the order of operation, because the order of operation defines the result of the operation. For the expected result and correct result, it is very important that you know the order of operation. Parentheses have the most precedence. So your compiler does first the parentheses, after that the exponentiation, after that unary plus, unary minus, and bitwise dot. After that it does the multiplication, division, floor division, and modulus, and after that it does addition and subtraction, and then bitwise left and right shifts, and then it does the bitwise AND, bitwise OR, bitwise XOR, bitwise OR, and then after that it does the comparison, identity, and membership operators, and logical operators has the least precedence. Because parentheses have the most precedence, you can change the order of operation using parentheses. I will show you many examples of that. In complicated calculations, you should define the order of operation yourself for correct result, for expected results. First, examples of arithmetic operators. You guys know this stuff from school. That's why I prepared this in advance to save time. The first example is 5 times 8 plus 3 divided by 9 minus 7. And in the second one, we change the order of operation to first do the addition on 8 plus 3 and then multiply it with 5. Here first happens the 5 times 8 plus and then 3 divided by 9 and then the addition and subtraction. Dividing a number by 0 will throw error, and the error will say 0 division error, division by 0. So if operators have the same precedence, then the compiler does it from the left to the right. Here we have exponentiation 8 to the power of 3. We will see the results in the console. And then here 39 modulus 4 and floor division of exponentiation, the result of this. Here the exponentiation happens at the end, here at the beginning. So the first one, the result of basic is 33, and basic 1 we change the order of operator 27.5, and the result of exponentiation is 512 because 8 times 8 times 8 is 512. You can also do it in your terminal. 8 times 8 times 8 is 512. Let us create here a basic calculator. User input, we get the user input, and here we use the if statement. Don't worry if you don't understand the if statement. We will talk about if statement later in this video. If plus operator is in the user input object, do something with that. So we first take the numbers user input dot split. Split is a method on a string that you can split a string in different parts, and I read part 1 and I convert it to integer. Also here numbers 0, the first part, and then I get the second part. The user input is always a string, so to do arithmetic operation on that, we need to convert it to number. So we concatenate strings together here, and then use comma because we cannot concatenate or join number with a string in Python. Let us copy and paste this 3 more times. Here for addition, here for subtraction, here for multiplication, here for now you see here that we are repeating this part 3 more times. If we use function, we can do it in one place and then reuse it. We will talk about function later in the video. Now let us try our calculator. Please enter numbers with operator. So I say here 5 plus 9 and I enter. And it says the result of 5 plus 9 is 14. Let us try another one. 7 times 2, and it says 7 times 2 is 14. Let us do the division. A long number divided by this one. Now subtraction. 1000 minus 100. 1000 minus 100 is 900. Our calculator works as we expected. Let us talk about comparison operators. Is equal 5 double equal sign is 5 equals to 6. It says false because it is not. The result of all comparison operators is Boolean, so false or true. Let us say not equal to, and it says true. 5 is not equal to 6. Change this to greater than. Is 5 greater than 6 is false. It is do the less than. Is 5 less than 6 is true. Less than or equal to, let's check that. Is 5 less than or equal to 6? It is true. Change that to greater than or equal to. Is 5 greater than or equal to 6? It says false. The greater than, less than or equals to, greater than or equals to, these 4 operators are used with numbers, but equals to and not equals to can also be used with strings and also with another data types. For example, is ABC same as ABC? Let's change this to result. It says true. So these two texts are the same. And you change that to not equals to. False. If you change that to something x, y, c, then you get true. Result is true. Logical operators. Let us create here some variables. So here we say is a greater than b and a less than c. It says false. 5 is not greater than 9 and this one is true and this one is false. For the AND operator, both parts must be true to give true result. If I change this to OR, then I get true. The result is true because this part is true. Here is the thing with AND and OR. AND operator and logical operator checks for false, and OR operator checks for true. Some junior developers think the opposite. They think that AND is checking for true and OR is checking for false. But no, AND is checking for false if it finds any false in the statement or in the expression. It stops and it returns the false. For example, here if I change this back to AND, the first one is false and it stops. It does not go through the second one. Let me prove it to you that it does not check the second one. And I change this to D. You see? And OR checks for true. And if it finds true in the expression, it stops. If I change this here for something true, B is less than C, or because it is now true, X equals to Y. These two variables, X and Y, are not defined. They does not exist in this context, in this file, in this program, and the compiler does not care at all. Let us check it. It returns true because this is true. If I change this to something else, B is less than A, it is false. So this will check the next one to find any true, and we will get an error. See, now we got an error that name error, name X is not defined. Let us do the not. Let us see the result. It says false. When you use the not, it reverses that. This is the result before not, and this is the result after not. Here we have one true, and this whole expression is false. So true false in AND operator is false. We reverse that using not, and it becomes true. You can also directly say here true, not true is false, and then if you change this to false, will be true. Identity operators. Let us create here a list. These are just stuff, just an example. Let us copy the above. The identity operators check if a variable, an object, is the same or not with the same memory location. So my items is my items 1, and it is false. Why? Because these two variables have the same values. Both are lists and they have different addresses in the memory. Let us create another variable, my address 2, and then refer to my items. And check here if my items is my items 2. It is true. Why? Because now my items 2 refers to my items. When you assign one variable to another variable, the new variable refers to the other variable. It does not copy its content in a new place, in a new address, but it just refers. We have two variables, my items and my items 2, but both took only one place in the memory. And then we have is not. It will be true because it is not. You can use comparison operator to check if they are the same, if they have the same value. And it says true. They have both the same values and the same contents, but they have two different memory addresses, and that's why it is not the same, but they are equal. Next, membership operator. You use membership operators to check if an object or an item is in another object. For example, I see PC in my item 1, and it says true because we have the PC inside of this list. We check something else, for example, it is false because we don't have TV in our list. But if we say not in, it will be true because TV is not in this list. Comparison operators, identity operators, membership operators, they all return us false or true. You can also have an array inside another array. For example, here I create an array called TV. False. Why? Because TV is in that list. Change this to n and run. Says true because TV array is inside of my items 1 array. Bitwise operators. It is do here bitwise operator and A1 and B1. The result of ANDing of 2 and 3 is 2. Why? Let me show you what is 2 in binary. This is 2 in binary. This is 3 in binary. The AND bitwise operator returns if both are 1. Both are 1, it returns 1, otherwise it returns 0. So the result is for 0 returns 0, for all the 0, 0, 0, 0, 0, 0, 0, and we have 1, 1, here 1, here 1, it returns 1, and the other one we have 0, 1, so it returns 0. That's why the result becomes 2 again. If we change it to something else, for example 5 and that one, it becomes 1. Why? The first one is now 5. For 5, the first one is 1, the second one is 0, so the 2 is 0 and the 4 is 1. This one 3 stays the same. For all the rest, we have just here 1, 1 become 1, the rest all becomes 0. We have 0, 1, 0, we have 1, 0, 0, and the rest is 0, 0 is 0. And it becomes 1. If this was 4, so this one was 0, and this one is 4, 2, and this one is 4, 4. It became back to 4, and it becomes 0 because we have here only 1, 1. Let us check it out. It becomes 4. And then next we have or returns 1 if one of the bits is 1. So here we have 5 and here we have 4. It becomes 5. Let us change the second one to 10. This one is 1, the second one is 2 and 4 and 8. So this becomes 1, the 4 is 0, 2 is 1, 8 plus 2 is 10. So it becomes 1 and the result will be 1 0 1 0 1 1 and then 1 0 1 and then 0 1 1, and we have all ones in the result, and it will be 1 plus 2 3, 3 plus 4 7, 7 plus 8 15. We should get here 15. Let's do the XOR. It will be the same. The difference between OR and XOR is that for XOR only one of the bit must be 1 to return 1. So if I change this here to 1, then the result will be 0. Now it is 1 4 5 5 and 8 is going to be 13. 13 and 10, it will be 1 2 3 3 4 7. The result will be 7. So only one of the bits must be 1 to return 1. So let us do the bitwise NOT on 13. So this is the A1 13. It inverts all the bits. The result is minus 14. 0 becomes 1 and 1 becomes 0. Minus 14 in binary is this number. Our computer represents 32-bit or 64 bits, but now this is only 16 bits. The next bitwise operator is 0 fill left shift. Shift left by pushing zeros in from the right and let the leftmost bits fall off. Let us see the result is 104. This is 13 in binary and our result is 104. Let me show you 104 here. So 128 is 0, 64 is 1, 64 plus 32 is 96, 96 plus 8 is 104, and this one is also 0. No, my mistake, this one is 0, 2, 4, 4 is 0, 8 is okay, and then 16, 0, 32, 1, 64, 1. Did the 0 fill left shift by 3, so this is 3 and we have here 3 zeros. This is 13. As you see here we have a pattern, 13 here at the beginning and the 13 became all here, and then we have 3 zeros at the beginning. So when you lose 3 bits, 3 zeros from the most left, then the computer has to fill in the beginning the same amount of zeros. Now let us do the sign right shift. Sign right shift shifts right by pushing copies of the leftmost bit in the from the left and let the rightmost bits fall off. We change this to other one. Let us see the result. So 1, 13 became 1. Why? This binary number became only 1. So this operator pushed 3 zeros at the left side so that these 3 first digits fall off. And we lost this 3, it became 1, entering 3 zeros here, 1, 2, 3, it became 1. Let us talk about assignment operators. The first one is equal sign. For example, z, and we assign a value to this 9. So this equal sign is assignment operator. You can combine arithmetic operators with assignment operators to do some shorthand operation and assign it to a variable. The result is 17 because 9 plus 8 is 17. Z minus equal sign 7. Now Z is here. Here it is 9. Here it is 17. So when you subtract 7 from this, the result is 10. Now you see here, the result is 10. Multiplication sign equal sign 2, and this has to be now 20. This is now 20. This is the same as you say Z assign operator Z times 2. Create a new variable 17 for example, and here 17 slash equal sign and then by 3, and here we print it is 5.666 and so on. This means that you divide 17 by 3 and assign it to the same variable. By doing the division, we got float. If we do floor division, we will get a rounded number. Now you see we got 5. Now let us do the modulus, and the result is 2. So when you divide 17 by 3, you will have a remainder of 2. Let us do the exponentiation. That is this number. This means
17 times 17 times 17 times 17 times 17.
And if I copy this and paste in my terminal, I get the same result. Let us do some bitwise operators. Bit and bitwise operator 5 and print it to the console is 5. Let me show you what is 13 in binary. 13, and this one is 8, so that one is okay. This one is 4, 4 is 1 is 12, and this one is 13, 7. If you don't know what I'm doing here, this is binary, and binary is base 2. It is not base 10, it is base 2. 2 2 2 2 2 and endless 2 and with the power. So the first one is 2 to the power of 0, which ends to 1. If you have 1, it means you have a value. If you have 0, it means you have nothing. That one is empty. So that does not count, and the result of adding a number with 0 is the number itself. So this is 2 to the power of 0, and we have the value, so it is 1. The second one is 2 to the power of 1, which makes it 2 itself, but we have here 0, so ignore that. And the third one is 2 to the power of 2, which is 4, so we have 1, so we have that. And the third one is 2 to the power of 3, which is 8, and we also have that because it is 1, so we have that. That's why here we have 8, 4, nothing, 1. So 8 plus 4 is 12, 12 plus 1 is 13, and here we have for 8 nothing, for 4 we have the value 4, for 2 we have the value, and for 1 we also have the value, because any number to the power of 0 is 1. I hope it was clear. When you do bitwise add operation on 13 and 7, if both is 0 or 1 is 0, we have 0, and here we have both 1 1, and here we have both 1 1 1 and 1 0, so both bits are not 1, so the result is 0, and that is why we get here 5. And next, let us do the bitwise OR operator. Is 13. Let us do the XOR. The result is 94. First, let me show you what is 73 in binary. 1, 2, 4, 8, 16, 32, 64. So for 64 we have 1, because the closest number to our number. For the 8 we have 64 plus 8 is 72, and plus 1 is 73. And let us make this 23. So this one is 16. For 16 we have a value 1, 0. We have value for the 4 to become 20. We have value for 2 to become 22, and we have 1 to become 23. For XOR operator, if only one of the bit is 1, it is 1. So for this one, you have 1 1, so it is not 1, it is 0. And then for the other one, we have here 1, and then here we have again 0 1, it will be 1. Here we have 1 0, it will be 1. Here we have a 0 1, it will be 1. And then here we have 0 0 will be 0, and then you have 0 1 will be 1. And when we convert this to decimal, it will be so 94. Let us do the 0 field left shift and see what it is going to be. This is a huge number, right? And why? Because when you let 23 zeros fall from the left, then you add 23 zeros at the beginning. Let us add 23 zeros at the beginning. Let us manually convert this to decimal. So we have 23 zeros here. Let us see how much is 2 to the power of 23. Exponent of this is to the power of 23, and then to the power of 24 is 0, 25 is 0, 26 we have the power of 26, the power of 29. Let us add these three numbers together, because here we have only 3 ones.
Control C, Control V plus, Control C, Control V plus, Control C, Control V.
Let us run the result again. Beat. See, this is what we got here, and this is the result. And here we print both of them. See, the result is that, and the expo is that we are doing here manually. Let us do the signed right operator on 23 is 0. So what happened? We pushed 23 zeros at the end and removed 23 bits from the beginning. So this was our number. This is 73 in binary. And when you add here 23 zeros, you remove 23 bits from the beginning, so we lose the part with ones, and it all become zeros. I hope it was clear. If it was not clear, please let me know in the comment so that I make another tutorial about bitwise operators.